Let t be a real number, and let p is a point xy on the terminal point, be the terminal point on the unit circle. Again, the unit circle is the circle with the equation of x squared plus y squared equal 1 at the center of 0, 0 at the origin, and the radius is 1. This meant that the value of x and y will have the maximum at positive 1 and minimum at negative 1. We define sine of t equal y and cosine of t equal x. So this function have the domain and range as follows. Since t is a real number, the domain can be any real number. The range, well, since it is on the unit circle, the maximum value is 1 and the minimum value is negative 1. If the point xy is the point on the unit circle, and this is of radius 1, I can draw a triangle on the unit circle. And draw the triangle. Now we will have, so t will be this angle, okay, and this distance here is y and here is x. Now by Pythagorean theorem we have x squared plus y squared equal 1. Previously we defined y equals sine of t and x equals cosine of t. This meant we have cosine squared of t plus sine squared of t equal to 1. Let's take a look at the next couple examples. Let's try to find the sine and cosine of special trigonometric angle using special triangle and unit square. What are the special trigonometric angle? These are the angles of theta equal 30 degree, 45 degree, and 60 degree. Or in terms of radian, we have pi over 6, pi over 4, and pi over 3. And we want to find this using special triangle and unit square. But what is special triangle that we're talking about here? The special triangle that I'm talking about is the equilateral triangle. First, I want to find sine and cosine of 30 degree. Okay. So let's say I have a unit quadrilateral triangle, which means all side here is 1. And each of this angle is 60 degrees because we have a quadrilateral triangle. With the property of the quadrilateral triangle, if I drop the latitude from one vertex to the opposite side, it will split this side into two equal parts. So this side here will be 1/2 and 1/2, and this angle is 30 degrees. So let's go ahead and highlight this triangle. And I will just draw it back out here and not to scale. And this angle here is of 30 degrees. This is of 60 degrees. We know this is a half. This is 1. Okay. So then, remember sine of 30 degrees. If you turn this, let's say we turn this so that the radius match with what we have on a unit circle. This is our radius. This is 1. This is 1/2. This is 30 degrees. This value here, x, y, is the point on the terminal, is the terminal point on the unit circle. And we can say that here y equal to 1/2. This telling us then sine of 30 degrees is equal to 1/2. Well, we can find x by using the Pythagorean theorem. So this here is x. X squared plus y squared equal 1. So then x squared equal to 1 minus y squared. That is 1 minus 1/2 squared. That is 1 minus 1, 4. And that is 3, 4. So x is equal to square root of 3 over 4. And we go with square root 3 over 2. 30 degree is an angle in quadrant 1. So that's why we go with a positive value. So then cosine of 30 degree is equal to root 3 over 2. Let's skip the 45 degree for now. Let's go ahead and try the 60 degree first, and we'll come back to 45 degree after. So before I move on to the 60 degree, let's take a look at this triangle again. So 60 degree is this value, right? And if I want to go ahead and turn it so that the 60 degree is on the triangle is matched up with the angle on a unit circle, then I'm looking at something look like this. If this is 60 degree, the hypotenuse here is 1. Then the one at 30 degree, the angle at 30 degree is facing the value of 1/2 here. So let's make this 1/2. This is a point on the unit circle. So this is, 1/2 is the one that facing 30 degree. So this is a half, the point x, y. So now we have x equal to 1/2. This means cosine of 60 degree is equal to a half. Sine of 60 degree is the value of y, and it can be solved using the Pythagorean theorem. So x squared plus y squared equal 1. X squared equal 1 minus y squared. That is 1 minus a half square. That is 3, 4. Again, 60 degree is an angle in quadrant 1. So then x is positive. This means x equal to root 3 over 2. I want to solve for y here. So change this to y squared. This is y squared. 1/2 is the value of x in this case. Again, this is an angle in quadrant 1. So y is positive. So then sine of 60 degree is equal to root 3 over 2. So let's go back to the theta equal to 45 degree. In this case, we want to use the unit square. The unit square is the square that have all sides equal 1. So this is 1, 1, 1, 1. And this angle are of 90 degree. If I draw the diagonal of the square, then this angle here is of 45 degree. So let's consider this triangle. One. Okay. I want to match this onto the unit circle. However, in order to do that, the hypotenuse of my triangle needs to be equal 1. So let's go ahead and calculate the hypotenuse of this triangle. The hypotenuse of this triangle is 1 square plus 1 square equal 2. So this is root 2. In order to match this hypotenuse of this triangle to be 1, I'll go ahead and divide this the side of this all of this triangle. We'll shrink this by square root 2 by a factor of root 2. So now I have a triangle smaller. This is 1 over root 2, 1 over root 2. And we'll map this onto the unit circle. So the hypotenuse here is 1. Now this angle is still 45 degrees. This point here is the terminal point xy. And as we can see here, x equal to 1 over root 2 and y equal 1 over root 2. So cosine of 45 degrees equal 1 over root 2. We rationalize the denominator to get root 2 over 2. And sine of 45 degrees equal 1 over root 2. Rationalize the denominator, we get root 2 over 2. Step 2. Use reference angle and reference number to find the value of the trigonometric function. To find the value of the trigonometric function. First, we'll find a reference angle or reference number. Evaluate the function at the reference angle or reference number. Then we determine the quadrant in which theta or t is located. Based on the quadrant, determine the side of the trigonometric function. Okay. For example, evaluate the following trigonometric function using reference angle or reference number. First, we could look at side of 11 pi over 3. So here t equal to 11 pi over 3. And this is greater than 2 pi. So let's go ahead and subtract 2 pi into this fraction. We get 11 pi over 3 minus 6 pi over 3. That makes 5 pi over 3. So 5 pi over 3 is a value that is in quadrant 4. T equals 5 pi over 3. That is in quadrant 4. That means sine of 11 pi over 3 equal to sine of 5 pi over 3. Now, because t is in quadrant 4, t bar is equal to 2 pi minus 5 pi over 3, and that is pi over 3. Because t equals 5 pi over 3, that is in quadrant 4, the value of psi is negative, and this value is less than 0, which means sine of 11 pi over 3 is equal to negative sine of pi over 3. We calculated earlier sine of pi over 3, that is equal to root 3 over 2. So now we get negative root 3 over 2. Cosine of negative 25 pi over 4. So t equal to negative 25 pi over 4. Again, we want to figure out what quadrant this is in. I'll go ahead and add 2 pi here continuously until I get a t value that is in the range of 0 to 2 pi. Now then I get this is negative 25 pi over 4 plus 8 pi over 4. That is negative 17 pi over 4. Again, I'm gonna add another 2 pi. And that is negative 17 pi over 4 plus 8 pi over 4. That is negative 9 pi over 4. and that is still a little bit greater than 2 pi. So we add another 2 pi. That is negative 9 pi over 4 plus 8 pi over 4. That makes negative pi over 4. Again, I want the angle that is in the range of 0 to 2 pi. So I'll go ahead and add another 2 pi. And this makes 7 pi over 4. So 7 pi over 4 is an angle in quadrant 4. So t equal to 7 pi over 4 in quadrant 4. This means t bar is equal to 2 pi minus 7 pi over 4. That is pi over 4. Because t bar is in because t is in quadrant 4, the value of cosine is positive, which then means cosine of negative 25 pi over 4 equal to cosine the pi over 4, and that is root 2 over 2. Okay. In the next one, we are looking at side of negative 405 degree. We're missing a degree symbol here. Yeah. So here we look at theta equal to negative 405 degree. That is greater than 360. Yeah, so I want an angle that is in between 0 and pi over 2. We go ahead and add 360 degree. And this makes negative 45 degree. I add another 360 degree. And that makes an angle of 315 degree. So theta is an angle in quadrant 4. This means side of the angle negative 405 is less than 0. So theta bar is equal to 360 degree minus 315 degree equal 45 degree. So sine of negative 405 degree is equal to negative sine of 45 degree, and that is negative root 2 over 2. Cosine of 900 degree. So start with theta equal 900 degree. We subtract 360 degree each time. This is a 180 degree. Okay. So cosine of 180 degree. Let's take a look where 180 degree is. 180 degree is right here. The terminal side of this is negative 10. If you look at the unit circle, that is the negative 10. Since we define the value of cosine equal x, this telling us that cosine of 900 degree is equal to cosine 180 degree equal to negative 1. So here we have the summarize of the unit circle here for you. You may want to have this unit circle handy with you at all time so that you can use it for all other problems that come later on in the semester. Ideally, you want to memorize this unit circle. The easiest way to memorize the unit circle is to remember everything in the first quadrant. And then you can use the reference angle to find the rest of the quadrant 1, 2, 3, and 4.